Sorry for the abrupt ending. I seriously thought I could squeeze it all in. So what are we doing? To recap, we were looking at an infinite open cover of 0, 1. And the open cover was 1 over n, 1 minus 1 over n, which has things of the form, say, 1/3, 2/3, 1/4, 3/4, right? So they're these kind of expanding things. And if you pick any element of 1 or 0, 1, the open set, eventually it will be covered by one of these guys. And so these green ones actually are an open cover of the open interval 0, 1. But they will not be an open cover of 0, 1 because you'll never have 0 in here and you'll never have 1 in there. So my fix for that was I'm going to include just 2 more open sets. I'm going to include all these green open sets, but I'm going to throw in these other 2 open sets. Negative 1/4, 1/4, and 3/4, 1/4. 1 and a fourth, sorry. So that means I'm going to include these 2 open sets, basically so I can cover my 0 and 1. They could be anything like that, but that's the basic idea. Now, this is a compact set. This was not a compact set. And I said that you have all these green open covers of this non-compact open interval 0, 1. You can't find any finite subset because if you took a finite number, that'd be the equivalent of just taking the longest one. And the longest one will just have length, it won't have length 1. It'll have 1 minus 2 over n. So it won't be covering everything. So you really do need all infinite number of these to cover 0, 1 open. But for 0, 1 closed, these green ones aren't sufficient. And so in order to have an open cover, you need to throw in something that's going to cover 0 and 1. And in particular, you're going to have to cover a little bit to the right of 0 and a little bit to the left of 0 because these have to be open. So when I do that, notice I can easily get a finite subcover here. So my finite subcover is just going to be, maybe I'll write it in black. Finite subcover of, what am I covering? I'm covering now the closed interval. Because 0, 1 is compact, I can find a finite subcover. If it weren't compact, I wouldn't be guaranteed to be able to find one. I might be able to find one. For instance, I told you that the open interval is 0, 1, which is not compact. Here's an open cover of 0, 1. 0, 1 is. That has a finite subcover, 0, 1, because there's only one thing in it. I almost held up one finger there. That'd be ridiculous because you can't see that. So you might be able to find a finite subcover, but not necessarily. With the open interval 0, 1, you can't find a finite subcover among the greens. Among these, the black, the closed set, you will be able to, and I'll show you how to do that right here. I'm just going to take negative 1/4, 1/4. I'm going to take 3/4, 1 1/4, and then I'm just going to take one that extends beyond 1/4 and beyond 3/4. So how about 1/8, 7/8? That's just one of these infinitely many of these. That's going to be enough where now if I do this one in blue, if I take these 2 red ones, red, red, and I throw in this one, you'll notice that all of the interval 0, 1 closed is covered. 0 to small starts right there, and then you pick up the blue and do the rest of it, and then the red will take you the rest of the way. So that's kind of how to picture geometrically what's going on with these open covers, finite subcovers.